And today, this section is on quadratic functions. Objective 1 is that we should be able to recognize characteristics of parabolas. Okay, so a parabola, remember, is the graph of a quadratic function. They can look like this, right? Or they can look like this. Yes? Y'all remember that? What is this point called right here? It's the maximum, but it's also called the vertex, right? And if you're over here, the vertex is a minimum. Now, one thing that we talked quite a bit about last year, but I want to re-emphasize because we use the idea a lot in the college algebra, is remember that this parabola is symmetric to this line that passes through the vertex, right? This is called the axis of symmetry. It's a vertical line, so what does what's this equation look like? Vertical line, so it's x equal a number, right? So axis of symmetry is always in the form x equals some number. So let's talk about some specifics about graphing these parabolas. So objective 2. If the equation is of the form f of x is equal to a times x minus h squared plus k. Remember that a can never be 0 because I got to have an x squared term for it to be a quadratic equation, right? For it to make the shape of a parabola, it's got to be x squared. So a cannot be 0. Does anybody remember what the name of this type of equation was? What kind of equation did we call it? What form was it in? It's exactly right. It's standard form. Now, think back. There were some things that we knew about the equation the minute I stuck numbers in certain positions. What does A tell me? It's a number. And what kind of information do I get about the parabola based on the number that A is equal to? If it's positive or negative, if A is positive, then what happens? It opens up. If A is negative, it opens down. What about H and K? They're going to be numbers, right? Anybody remember what H and K, what those numbers are? It's the vertex, right? That gives me the exact location of the vertex. So if that's the location of the vertex, then x equals h has to be the equation for the axis of symmetry. Right? So is x equal the x coordinate of the vertex? Okay. And then in the process of graphing the parabolas, a lot of times when we graph any kind of curve, we want to know where it crosses the x and the y-axis. So the x-intercepts, remember, are where we cross the x-axis. And the way we always find x-intercepts is we take the equation and set it equal to 0. So we let f of x become 0 and we solve it. The y-intercept are found not by letting y be equal to 0, but by letting x be equal to 0. In function notation, it's written that way. We want f of 0. So in other words, everywhere there's an x, you're going to replace it with a 0. Find the y to go with it. Okay, so those are the pieces that you need. And if you have those pieces, you can draw the parabola very quickly and easily. So check point 1. Let's just apply that. Let's graph f of x equals negative x minus 1 squared plus 4. Okay, so what are some things that I know right off the bat? It opens down because of the negative, and that's actually like a negative 1, right? Do I know the vertex? Is it negative 1, 4? How about 1, 4? Remember, inside the parentheses, you always take the number, it changes the sign because the formula is x minus that number, and so that's x minus a positive 1. Okay? So there's my vertex. That means my axis of symmetry is what? X equals 1. And now if I want to find the x-intercept, I set that equal to 0. So 0 is equal to negative 1 times x minus 1 squared plus 4. Now we spent quite a bit of time in Chapter 2 talking about how to solve this type of equation. What's the easiest way to solve this equation? Subtract 4 from both sides? Because I can use the square root technique, right? Get the square root by itself. So I've got negative 4 is equal to negative 1 times x minus 1 squared, because that's a 0 pair and it just drops off. Then what do? Divide by that negative 1. So I've got positive 4 is equal to the x minus 1 squared. Take the square root of both sides. So I get a positive and a negative 2 is equal to x minus 1. Right? When I take the square root in the process of solving an equation, I get a positive and a negative value. I've got to add 1 to the other side. So I've got 1 plus 2 for one answer, and I've got 1 minus 2 for the other answer. And then you just solve them. So x is 3, and x is negative 1. And then my y-intercept, I find by replacing all the x's. So f of x is equal to negative 1 times 0 minus 1 squared plus 4. Right? F of 0 is where I put 0 in for x. That's what that means. So I've got negative 1 times negative 1 squared plus 4. So I've got negative 1 times 1 plus 4, right? Now with me? Negative 1 squared is positive 1, and positive 1 times negative 1 gives me back negative 1. So I got negative 1 plus 4, which is 3. Now, once I have all of that information, I can very quickly draw that graph. Right? So, what did I say first? Where's the vertex? At 1, 4. It is going to open down, so I'm going to be looking at coming here, right? What was my x-intercept? Positive 3 and negative 1. And my y-intercept was what? Positive 3. And so from that information, we can draw the graph, and then always make sure and look that when you draw it, you've drawn it so that it's got that symmetry going on. The left side of the line x equals 1 looks the same as the right side. Okay? So you just take all that information that you just found and you plot it and you draw the parabola. Okay? It gets faster though. Okay. We got that? Check point 2. We have that f of x is equal to x minus 2 squared plus 1. So is it going to open up or open down? Okay, and what's my vertex? 2, 1. And so my axis of symmetry? It's x equals 2. So whatever the 2 is in the vertex. I mean, whatever the x coordinate is in the vertex. Yep.
Is it like x plus 2 squared? Would it be negative 2?
Yep.
Why is the vertex?
Because my formula is that it's x minus h squared. So the minus sign is part of the formula, and then it's a positive 2 because if h was negative 2, it'd look like x plus 2, right? Okay. Then we want our x-intercept. The way I find that is I say 0 is equal to x plus 2 squared plus 1. What? Oh, I'm sorry. Looks like I drew that line in there. Thank you. Okay, we good? Now, I'm going to subtract 1 from both sides. So negative 1 is equal to x minus 2 squared. What happens when I take square root of a negative number? I get an imaginary number, and I can't use that to graph with, so I'm not going to even do it. No. There is no place where it crosses the x-axis is what that means to you. Okay, if you get an imaginary number, that means there's no real number value for that. It's not going to cross the x-axis. Think about it for a minute. If the vertex is up there at 2, 1, and it opens up, is it going to cross the x-axis? Probably not. Okay? So the y-intercept is something we really need this time. So I want f of 0. So I got 0 minus 2 squared plus 1. 0 minus 2 is negative 2. Negative 2 squared is 4, and 4 plus 1 is 5. Right? Okay, so I'm going to take all my information. So I've got my vertex at 2, 1. My y-intercept is at positive 5. Now, I don't have another point. How can I tell where to draw the other side? The axis of symmetry. Because I know that there's an axis of symmetry that goes right through here. So if I went over 2 and up 5 to the left, what's going to happen? Over 2 and up 5 to the right. And once I have 3 points on a parabola, I can draw my graph. Okay? That's what you do if they give it to you in standard form. Now, we also talked about these quadratic equations in a different form. We called it general form, when it was set equal to 0. Or set equal to y.